Okay. Yeah, as we return, Professor Dr. Dolphy Gilpin here, and we're continuing with silver. This is silver, atomic number 47, and atomic mass of 107.868. And we'll do a little notebook here as we continue. I said we're going to do a couple reactions with silver. Remember now, its electronic configuration is krypton, either 4d10 5s1, something like that. Krypton 4d10 5s1. Yeah. So here I'll start off with some reactions. And we had to give him some reaction in the initiation stage. First, we mentioned some uses now, about 10 uses, and we say it's used in alloys, in batteries, it's used also in dentistry and medicine, gas coating, lead as light emitting diodes, chips, nuclear reactions, photovoltaic cells and solar cells, and photography, solar, and RFID chips, it's using RFID for tracing parcels and shipments. Using touch screens, and what is also this? In some water purification. It's also using water purification, and wood preservative, and there are other uses, but we just mentioned about 10 there. And so and a little note on it is that in ancient Egypt, it was worth more than gold. So in ancient Egypt, the silver was valued much more than gold. That's a little note. In modern times, it's the reverse here. Gold has much more value than silver, but in ancient Egypt, they said it back in the times there, it was valued much more than gold. All right, so as we continue, Ag, silver, reactions. First, we have a melting point of 961 degrees centigrade and a boiling point of 2210 degrees centigrade, a density of 10.49 grams per cm cube, and it reacts with hot concentrated sulfuric acid, yeah, we know that, and nitric acid. It will also react with aqua regia. Likewise, gold will do the same thing, but we'll get on when we move on to gold. So aqua regia is a solution of what? I believe nitric acid and hydrochloric acid. And the combination of that, no, I think it's something chloride. The combination of that and hydrochloric acid uh, some form of chloride and cause the removal. Well, we do it for gold, but I guess it will be similar for silver, the aqua regia solution. But let's see exactly what it's composed of. So we say it react with concentrated sulfuric acid and nitric acid and with aqua regia. So I have Ag plus aqueous Cl minus give rise to AgCl, which is silver chloride. So I guess this could have been Ag plus hydrochloric acid, which will be dissociated into the chloride ions. And the chloride ions will attach itself to the silver to give you silver chloride. So that means you have to watch silver with chlorine solutions and things like that, because it will the chlorine will react with the silver, and so change its value or its appearance. So here again we have silver chloride 2, AgCl2 plus 2 ammonia yields now this complex AgNH3 bracket 2 and all bracket plus Cl minus aqueous. So it's a complex silver ammonium sort of ion plus the chloride ion. So like the silver and the ammonium ion like, and the chloride will be separated in chloride ions. And another reaction will be this, a similar one with Ag bracket NH3 bracket 2 all bracket plus, that's the ion, aqueous solution plus Cl minus aqueous plus 2H plus aqueous. A reversible reaction will give you silver chloride plus some ammonium. NH4 would be ammonium. NH3 is ammonia and NH4 would be like some ammonium ion. But the important thing here would be the silver chloride. So that silver itself would be altered and into silver chloride. Let's go to some more reaction here. So we have silver plus sodium hydroxide here, and well, at this moment I would say, excuse me, we don't have a board as yet. The board, projection board, is for video imaging, and I used to have my own chalkboard and things, but that's why I'm doing it by vocalization and by audio here. So we have 2 silver plus ion aqueous plus 2 hydroxide ion aqueous. With a reversible reaction here, give you Ag2O S, which is a solid, which is some form of silver oxide, plus H2O. So that is with silver and sodium hydroxide. Instead of getting silver hydroxide here, you get silver oxide. And the hydrogen, instead of getting hydrogen, you get water combined with the hydrogen to give you water. So you get silver, some form of silver oxide here, Ag2O, which is a solid, and water. And I guess the sodium would have to be some form of sodium ions. I don't think it will be independent, but we'll see. Silver plus ammonia. So we have 2 Ag, aqueous, plus 2 NH3 aqueous, that is silver plus ammonia plus water. You get a reversible reaction of silver 2 oxide again, Ag2O, and we get 2 NH3 plus aqueous and H2O liquid. So those are some reactions of silver with silver and sodium hydroxide and silver and ammonia and silver and concentrated sulfuric acid and silver and nitric acid and silver and aqua regia. Those are some of the solutions with silver.